Hey guys, welcome back to a new video. So in today's video we are going to cover visualizing feature maps of VGG16 model. So this is going to be a very simple tutorial, but I'm going to cover a lot of different broad concepts in very short time. So from the title you can understand that I am simply going to plot the feature maps. So whatever feature maps I get out of the VGG16 architecture are going to be displayed in the form of an image. That's going to be the main agenda of this video. Now, which layer am I going to plot? Well, let's see that when we get there. But for now, if I have to show you the main agenda, then we are going to cover all these different topics today. So first is I'll try to create a storage account in Azure, and inside of the storage account I'm going to create a blob storage wherein I'm going to store a particular data set. Now this is a Kaggle dataset. I'll show you the dataset as well. So I'll be uploading a zip file to my storage account. Just a second, let me take a pointer. Okay, so uh, yep. Okay, so I'm going to upload a zip file to my storage account, and then I'll create a workspace. So I'll be creating both of these resources today, and when I'm creating my machine learning workspace, I'll try to use the same storage account that I've created. I'll create a zip file which will be uploaded to the storage account. Inside of my workspace, I'll create a data store where I'm going to use the zip file that I have uploaded here. Okay, now after that I am going to give a small simple tutorial on Python SDK, and in this Python SDK I'll be using the data store that I've created, and I'll try to unzip the data set so that I can have all of the images from all the different classes. Then we'll have a very high level overview of the VGG16 architecture, and then I'm going to use the feature maps to plot them. So these are going to be all the different steps that we are going to cover today. So let's get to the first one, the storage accounts. But before we go there, I'll just show you guys the data set that I'm going to use today. Okay, so this is the data set. It's a Tom and Jerry data set, and it has 5000 plus images, and there are 4 classes, I believe. Let me scroll down. Yeah, here you can see there are 4 different classes. For now I need only like 5 or 10 images just for the purpose of this tutorial, but you guys can go ahead and explore this dataset. It's a really fun dataset and a lot of people have played around with it. So I've downloaded this, and the zip file itself is of 556 megabyte. Now let's go ahead and create a storage account. Okay, here we are in Azure. I'll say YouTube storage account, Sai Ram YouTube storage account, testing resource group. I don't want to change any other parameters here, nothing related to networking, and no VNet, nothing. Let's create it. Okay, let's go ahead and create. This should not take much time. Okay, this is done. Let's go to the resource. Storage browser, blob container. Now I'm going to create a blob container here. Let's call this as YouTube dataset or YouTube blob created. Okay, this is done. Now inside of this, let's upload the zip file. Tom and Jerry dataset.zip, upload. It's gonna take a while to upload because it's 400 MB. In the meanwhile, let's go ahead and create a machine learning workspace. I'll use the same resource group, Sai Ram YouTube workspace. Now for the storage account, instead of new, I'll select Sai Ram YouTube storage account. You can leave the key vault, you can create a new application inside and everything. Yeah, I'm going to delete this later on anyway, so let's just go ahead and create this. Okay, validation passed. Create. This might take some time though, but it is fine. We can wait. Okay, that is quick. Okay, the blob has been uploaded. Okay, come on. Okay, deployment complete. Let's go to the resource. Let's launch Studio. Here we are. Now I'm going to use notebooks, but before we go there, I'll have to create a data store. So let's do that first. Let's create a data store, create it. I'll say YouTube data store, blob storage, that is right. Use this storage account, use this blob account key. Okay, let's get that account key. This is the storage, right? Yeah. Access keys, copy this, come here and paste it, create. Okay, now data store has been created. I can go ahead and create a data asset as well, but for now I'm just going to stick with my data store. Okay, this should be fine. Let's go ahead and use a notebook. Now in order to create a notebook, I'll have to create a compute instance. I can't use a notebook without any compute. I can create either compute instance or a compute cluster. Since this is just a simple tutorial, I'll just need a instance. Okay, let it pick the name automatically. Now you can choose whichever machine you want. You can try to customize this configuration as per your requirement. For this tutorial purpose, anything will work fine. So I'll simply use the default ones. Next, scheduling. Usually I try to put the SSH connection enabled, but I don't need it for now. So let's go next, next, next. By the way, whenever you're creating resources for tutorial purpose or for demo purpose or for testing purpose, try to add a tag so that you can get rid of all of them at once easily, and also you can verify that all of your testing resources have been deleted properly. It's a good practice. Okay, let's create. Okay, so right now I'm under compute instances and this is getting created. uh, Creating, come on. So once this has been created, I can simply use either a Jupyter Notebook or a Jupyter Lab or a VS Code option or Azure Machine Learning Notebook. So I'm going to use the Azure Machine Learning Notebook for now. Deploying a compute instance usually takes like a little bit of time, but a compute cluster will take somewhere around 25 to 30 minutes to create. So instance is way quicker. Let's go into the data store. Here you can see browse option, right? From here on you can try to see your data, you can preview it and make sure that everything is properly working and make sure that it is the actual data set that you are going to use. Okay, this has been created. So here you can see I can open a Jupyter Lab, Jupyter Notebook or a VS Code directly from here, but let's go to notebooks. I'm going to create a new file. Actually, I already have a notebook with me, so I'm going to explain you the code in that notebook and then we can upload it here and we can use it directly. Okay, if I just say print hello world, there you go. Okay, so this is working fine. Now I'll delete this and let me upload this notebook. Open it. Okay, now let's go through the notebook. First and foremost, let's import all of the necessary libraries. OS is very simple, NumPy and Pandas are very simple. Zip file is basically a library that I'm going to use to unzip my zipped file, unzip my data set. Now, this is where Python SDK begins. Okay, so from Azure ML.core, I'm importing two different things. So one is going to be data set, workspace, and a data store. Okay, so why do I need three? Let's take a look at it. But workspace is pretty much important. Now whenever you're importing workspace, you have to connect to that workspace. Since I'm running this completely on completely on my workspace itself, I don't have to give any username, password, or anything. But if you're running this notebook on your local machine, then you might want to use the proper credentials. So where can you find those credentials? If you go to Azure portal, uh, if you go to your workspace, here you can see download config.json. This file will contain all of the different credentials that you want to use, and based on that you can use the config file. You can just upload it here simply, and you can run the exact same code. That should help you connect to your workspace. Let me run this. I'll collapse this for now. Let's connect to the workspace. Okay, now comes mounting. Now what is mounting? Whenever you're using a data store, what it does is, the way Python SDK handles it is, if you see this line here, with dataset.mount. So over here, I'm just simply connecting my Python code to the dataset. So whatever data store that I've created just now, I'm connecting it to that. Now, when I say .mount, as long as I write my code inside of the with statement, I'll be able to use it, because when I say mount, this workspace is going to be attached to this blob storage. Okay, or you can simply say this notebook is going to be attached, or sorry, this compute instance is going to be attached to the blob storage. The moment I come out of my with block, the mounting is going to be removed. So once I unmount it, the temporary connection which was present previously will go away, so I can't use the dataset again. Okay, so that is the main context of mounting. Mounting is basically establishing a temporary connection. So if you look at the code here, I'm simply saying from my workspace, get this data store. I believe the data store name is a little different now. Okay, this is the name of the data store. Let me copy this. I'll go here, paste. Okay, so here you can give kind of the different patterns that you can find for your data set. So let's say if your data set has patterns like class 1 slash img1 img2 img3 so on, and class 2 slash img1 img2 img3, instead of importing all of them at once, you can simply say class 1 slash img star dot png. So you can give it like this. So all the different files that are falling under this pattern will be imported. But for now, since I have only one zip file, I'm going to import it directly. So before importing, I just want to print all the different files that are present in the blob storage. Let me run this. Oh, missing required package. Oh, that is fine. I'm using the basic default kernel. Let's switch it into Azure ML. So Azure ML is a kernel that comes with a lot of different machine learning related packages pre-installed. Okay, I might have to refresh the page. This is a very common problem. So whenever we are switching kernels, it doesn't go very smoothly. Okay, if you are connected to Azure ML, run. Okay, connect, imported. Now run this, connected, and this should mount. Yep, there you go. So here I can see the zip file. If I create any other folders or files inside of my blob, then all those will be displayed as well. Azure, this one. Okay, so I can just simply create a new file here, and the same thing will pop up here. Now that we have the zip file, we are going to unzip it. So I'm using the same line here with dataset.mount. With dataset.mount, I'm taking the path, the temporary path, and I'm taking the zip file name, and I'm simply doing an os.path.join so that I can get my file path. I'll take that file path, the temporary file path, I'll extract it directly to the root directory. Let's run this. Again, this might take a bit of time because as I said, this is a very huge data set. There are 5000 plus images. So I'm not going to extract this completely. I'm just going to stop this process midway once I get like enough number of images. Here you can see the moment I refresh it, I've already got 2 CSV files and 1 folder. Okay, cool. A lot of images have been imported. Sorry, a lot of images have been unzipped. Okay, so this has been done. That took quite a lot of time. Okay, if I refresh, I should have all the classes. There you go, 4 classes are present here. Now let's take a look at the actual visualization part. Now, what am I doing here? First thing is, I'll simply create a data frame out of all of this, where I am going to take the image file and the image label. So label is basically the uh, class name that they have given in the uh, suffix of each file. If I can show you, okay, here you can see these are the 2 different labels, and now I'm going to write a simple function which is going to give me a random image every time I run it. So if I run this, well, honestly, I don't need this line. Okay, yeah. So every time I run, this is going to give me a new random image path. Uh, Remember this function, I'm going to use it later on. Now it's time for the VGG16 model. Okay, so from torch vision, I'm importing this model. Okay, let's import this. So I'm not importing it with the weights, I'm importing just the raw model architecture. Reason being, I'm not going to do any predictions or model training or anything. I'm simply going to use the model architecture to visualize. Okay, so that is done. Now let's take a look at all the layers that are available in the model. So if I say my model dot children, and if I list all of the different layers that are available from the first block, which is the main block actually, then I'll print each one of them, and here you can see these are all the different layers that are present. Okay, so this is from the first block. Here you can see the 0, right? So the first block is the main architecture, and the second block is where you customize it based upon your necessity, based upon your requirement. Okay, so here you can see the very first layer is a convolution 2D layer, and the second one is relu, con 2D again, relu again, so on and so forth. From all of these, I simply need only some of them. Okay, yeah, so I really don't need any max pooling layers in this. So for the visualization purpose, I need only convolution layers. So let's go ahead and run this. Here is a simple function that will extract the convolution filters and plot them for a layer. Let's see. Okay, so this is the plot filters function that I'm going to use later on. You can just simply take a look at this function. It's a pretty simple one actually. So from all the layers, I'm taking the index, okay, and then that is going to be my filter, and then I'm simply going to use that filter and I'll plot the output image. Okay, now here you can see I'm saying that I don't need all the different layers, I just need my convolution layers. So if I run this cell, this is going to show me all the different indexes wherever I've got a convolution layer present. Now when I plot my layer indexes, this index is 28. So these are the convolution filters present in the 28th layer. If I say 19, okay, if I say 19, these are the filters that are present in my 19th layer. Okay, these are filters, convolution filters, 3 by 3 filters. Okay, once I apply these filters on the image, you can see the feature maps. Okay, so let's go ahead and plot them. Okay, I'm not going to run this cell because it's going to ask me to import the load image, but I'll have to fix the Keras version for that again, so I'm not going to bother with that. But here you can see I'm just importing a random image and then I'm loading it. This is my random image. Now I'm going to take a partial model. Okay, I'm not going to take all the different layers, I'll take only partial model. So let's say if I want to see what is happening in the first 3 layers, then I'll take these 3 layers. Again, you will have to use these indexes, by the way. Okay, so once I take my partial model, this is my transformation steps where I'm just simply resizing my image, because the first layer, here you can see, first layer takes 64 channels, 64 by 64 image. So I'm resizing my image into 64 by 64, convert that into a tensor. And where am I using this trans image? I'm taking the image that I've loaded here. I'm taking this image, I'm passing it to my transformation steps here, and then the trans image is going to be a tensor of size 64 by 64. 3 channels, by the way. Okay. Now here you can see with torch.inference mode, I'm taking my partial model and I'm doing the predictions. Predictions as in I'm passing my image into that model. So what is my model going to return now? It's going to return whatever is in the last layer. Okay. Those are the feature maps. Now I'll take my feature maps and I'm simply plotting them. Okay. So if I go here, out of all these different feature maps, I'm plotting them in 8 by 8 format. So here you can see these are all the different feature maps that I've received for this particular layer. You can customize the layer index value, and maybe let's say if you want to find out what is happening inside of this layer, or maybe if you want to find out what is happening in the very first layer itself, then you can change the layer index here, observe the convolution filters, you can change the layer index here, this will automatically change your partial model, and then you can do your predictions, you can plot your feature maps on the partial model. Excuse me. So that's kind of how you visualize the feature maps of a VGG16 model. And since this is a very generic code, you can replace a VGG16 model with any model of your choice. Okay, so where is this? Yeah, so this part can be replaced with any other model as per your requirement. I hope you guys have enjoyed watching this video, and I really hope I was able to teach you guys a couple of things new today. And if you have made it this far into the video, thank you so much for watching, and see you guys in the next video. Thank you for watching. Bye.